Have you ever pondered the existence of a dimension beyond our three-dimensional world? This may seem like a question straight out of a science fiction novel, yet it's one that has been contemplated by some of the greatest minds in physics and mathematics. To unravel this mystery, let's first understand what we mean by dimensions. A dimension is essentially a direction in which we can move or measure. The world as we know it is made up of three dimensions: length, width, and height. These are the spatial dimensions that define our physical reality. Imagine a line. This line has only one dimension: length. It's a straight path from one point to another with no deviation. Now, if we take this line and drag it sideways, we create a shape with two dimensions: a square. The square has both length and width. We've added a new direction in which we can move: sideways. If we now take this square and pull it upwards, we create a cube. This cube has three dimensions: length, width, and height. We've added yet another direction: upwards. This is the world we're familiar with, a world of three dimensions. But what if there's more? What if there's another direction that we can't see or perceive because we're confined to our three-dimensional space? This is where the concept of the fourth dimension comes in. It's a realm beyond our grasp, a direction that exists outside our three-dimensional understanding. Just as a two-dimensional being on a flat surface would struggle to comprehend a cube, we, as three-dimensional beings, find it challenging to envision this fourth dimension. Yet, just because we can't perceive it, doesn't mean it doesn't exist. This unseen dimension, this fourth dimension, could hold the key to understanding some of the greatest mysteries of our universe. So, if we live in a three-dimensional world, could there be a dimension that we can't perceive? Imagine a world where time folds upon itself, where future, present, and past coexist. Welcome to the fourth dimension. The fourth dimension is a concept that has intrigued and challenged thinkers for centuries. It's a realm that's often represented as time in physics. While the first three dimensions, length, width, and depth, are spatial and can be measured physically, the fourth dimension is a temporal one. It's not something we can see or touch, but it's a concept we can understand mathematically and theoretically. In the realm of physics, the fourth dimension is the backbone of theories that explain the workings of our universe. It's a cornerstone of Albert Einstein's theory of relativity, which paints a picture of space and time as intertwined in a four-dimensional fabric called space-time. In this context, the fourth dimension allows us to understand how gravity works, how light travels, and why time seems to slow down as we approach the speed of light. But the fourth dimension isn't just about time. It also represents a space that is beyond our three-dimensional perception. If we were to step into the fourth dimension, we would see a world that is unrecognizable, where the laws of physics as we know them might not apply. We could see all sides of an object at once, or pass through walls as if they weren't there. However, despite its abstract nature, the fourth dimension is not beyond our comprehension. Through mathematics, we can describe it, analyze it, and even visualize it. We can use equations to predict its properties and behaviors. And with the aid of computer simulations, we can create models that give us a glimpse into this strange and fascinating realm. So while the fourth dimension may seem daunting and elusive, it's a testament to the power of human curiosity and ingenuity. It's a reminder that there are worlds beyond our immediate perception, waiting to be explored and understood. The fourth dimension, in essence, is a realm of beyond sight, beyond tangible, but not beyond comprehension. Now let's dive deeper into the fourth dimension with a concept that may seem like it's straight out of a science fiction novel: the Tesseract. In our quest to understand the fourth dimension, we come across an object that embodies its principles in a rather mind-bending way: the Tesseract, an entity that seems to defy our understanding of space and time, yet is as real in the realm of mathematics as the number 2. So what is a Tesseract? Simply put, it's a four-dimensional analog of a cube. Just as a cube is a three-dimensional extension of a square, a tesseract is a four-dimensional extension of a cube. But before we dive headfirst into the tesseract, let's take a step back and consider its lower dimensional relatives. Picture a line, a one-dimensional object. Now extend that line at a right angle and you get a square, a two-dimensional object. Similarly, if you extend that square at a right angle, you get a cube, a three-dimensional object. The cube has length, width, and height. It exists in the three dimensions that we are familiar with. Now here's where things get tricky. To get a tesseract, you would, theoretically, extend the cube at a right angle. But wait, we've already used up all our dimensions. This is where we venture into the realm of the fourth dimension. A tesseract, also known as a hypercube, has sides that are all cubes. Imagine that. It's like a cube, but with an extra dimension squeezed in there. Each corner of a tesseract is connected to 4 edges, just like a cube, but each edge connects 2 cubes rather than 2 squares. This idea may seem almost impossible to visualize, and that's okay. Our brains are wired to understand the world in 3 dimensions. But even if we can't fully comprehend a tesseract, we can appreciate the beauty of its concept. Just as a cube exists in 3 dimensions, a tesseract exists in 4. Hard to imagine, isn't it? While we can't physically see a tesseract, we can attempt to visualize it in our 3-dimensional world. Let's dive into the fascinating process of visualizing a tesseract. The first step requires an understanding of dimensions. We live in a world of 3 dimensions where every object has length, width, and height. A 2-dimensional object, like a drawing, has only length and width. But what about a 4-dimensional object? It's hard to imagine because we're not equipped to perceive or interact with the 4th dimension in our everyday lives. Now let's think about how we can project 3-dimensional objects onto a 2-dimensional surface. Imagine you're holding an apple under a bright light, casting a shadow on a flat surface. The shadow is a 2-dimensional projection of the 3-dimensional apple. It gives you an idea of the shape and size of the apple, but it doesn't capture the full essence of the apple's 3-dimensionality. In a similar fashion, we can project a 4-dimensional tesseract into 3-dimensional space. The result is a 3-dimensional shadow of the 4-dimensional tesseract. It's a bit like a cube within a cube, connected by lines representing the 4th dimension. But remember, this is only a projection. It gives us an idea of what a tesseract might look like, but it doesn't capture the full essence of its 4-dimensionality. Visualizing a tesseract is a mental exercise that stretches our understanding of space and dimension. It challenges our perception and forces us to think beyond our 3-dimensional confines. It's a bit like trying to explain color to someone who has never seen it. Words and diagrams can only do so much. The true nature of a tesseract, or any 4-dimensional object for that matter, remains largely unfathomable to our 3-dimensional minds. So, while the full reality of a tesseract remains beyond our grasp, we can get a glimpse of it through these projections. The power of the tesseract lies not only in its mathematical and scientific implications, but also in its ability to push the boundaries of our imagination. The 4th dimension and the tesseract, while abstract, are not just idle musings of the mind. They have real impacts on the world of science and technology. Now you might wonder, how does this seemingly abstract concept find practical applications? Let's delve into that. The concept of the 4th dimension is used extensively in various scientific fields. For instance, in physics, the idea of a 4-dimensional spacetime has become a cornerstone of Einstein's theory of relativity. It combines the 3 dimensions of space with the 1 dimension of time into a single 4-dimensional continuum. This groundbreaking concept has allowed us to better understand the universe and the way gravity works. In the realm of computer graphics and animation, the concept of the 4th dimension is also used to create more realistic and complex images. It allows animators to manipulate objects in a way that would be impossible in a 3-dimensional space, providing a sense of depth and perspective that is unparalleled. The 4th dimension also plays a significant role in string theory, a theoretical framework in which the point-like particles of particle physics are replaced by 1-dimensional objects called strings. In string theory, there are actually 10 dimensions, and understanding the 4th dimension is an essential step to comprehend the full scope of this theory. Now, let's shift our gaze to the world of mathematics. Here, the 4th dimension and the tesseract are used to solve complex mathematical problems. For example, in the field of topology, a branch of mathematics concerned with the properties of space that are preserved under continuous transformations, the 4th dimension is used to study objects and problems that are too complex to be solved in 3 dimensions. In essence, the 4th dimension, though abstract, provides us with a powerful tool to understand and manipulate our universe. It opens up new possibilities and challenges our understanding of reality. The 4th dimension might be invisible to us, but its influence is undeniable. So, the 4th dimension remains largely a mystery, but that doesn't mean it's beyond our understanding. We've journeyed through the unseen dimensions, wrestled with abstract concepts, and challenged our perceptions to visualize a tesseract, a 4th dimensional object. This has been no small feat, as these concepts push the boundaries of our everyday experience. Yet, it's through this exploration that we're able to grasp something as intricate and elusive as the 4th dimension. From the outset, the 4th dimension has presented itself as a paradox, a realm beyond our 3-dimensional understanding. Yet it's precisely this paradox that draws us in, inviting us to explore, to question, and ultimately, to learn. We've seen how the Tesseract serves as a bridge between our three-dimensional reality and the mysterious fourth dimension. As a hypercube, it's a concept that challenges our understanding of space and time. But why does this matter? Why do we need to understand the fourth dimension and the Tesseract? It's simple. Our understanding of the universe and our place in it is fundamentally tied to our understanding of dimensions. When we understand more about the fourth dimension, we're not just unlocking the secrets of a Tesseract. We're unmasking the universe itself, peeling back the layers of reality to reveal a world beyond our own. In many ways, the fourth dimension is a testament to the power of human curiosity. It's a reminder that despite the complexity of the universe, we're driven by a desire to understand, to question, and to explore. It's this curiosity that's brought us here, to the edge of the known universe, standing on the precipice of the unknown. As we stand on this precipice, we're not daunted by the abyss of the unknown. Instead, we're excited by the possibilities that lie ahead. We're ready to face the challenges, to question the assumptions, and to push the boundaries of our understanding. Because we know that with every step we take into the unknown, we're not just exploring the fourth dimension, we're exploring the infinite expanse of human potential. As we continue to push the boundaries of our knowledge, who knows what other dimensions we might uncover. As we stand on the brink of this dimensional frontier, we can't help but wonder, what's next? We've explored the concept of the fourth dimension, we've visualized the Tesseract, and we've started to understand its power. But where do we go from here? The future of the fourth dimension is a vast landscape of possibilities ripe for exploration and discovery. It's a new frontier that promises to revolutionize our understanding of the universe and our place within it. Just as the 19th century discovery of electromagnetism paved the way for the technological revolution of the 20th century, the exploration of the fourth dimension could lead to advancements in science and technology that we can scarcely imagine today. The fourth dimension holds potential for breakthroughs in physics, mathematics, and even computer science. Researchers are already exploring the use of four-dimensional models in quantum physics, with the potential to unlock new insights into the fundamental nature of reality. In mathematics, the study of higher dimensions is helping to solve complex problems in topology and geometry. In computer science, the concept of the fourth dimension could revolutionize the field of machine learning and artificial intelligence. Imagine algorithms that can process data in 4 dimensions, leading to more powerful and efficient AI systems. The possibilities are truly mind-boggling, yet, for all the potential that the fourth dimension holds, it's important to remember that we are just at the beginning of this journey. There is still so much to learn, so many mysteries to unravel. But that's what makes it so exciting. The fourth dimension is not just about the discoveries we make, but also about the questions we ask, the ideas we explore, and the boundaries we push. So, what's next for the fourth dimension? The answer is, we don't know. And that's what makes it so exciting. The future is not written, and the fourth dimension is a blank canvas waiting for us to paint our discoveries upon it. In this journey of discovery, the fourth dimension is not the end, but rather just the beginning.